Okay, welcome back. So we started the last topic on the arithmetic, that is percent, in the last class, and we want to conclude on the topic in this class and to wrap up on the first aspect of the GRE quantitative reasoning, that is arithmetic. So we are treating the last topic, and this is the concluding part of the lecture. So I want to believe you have gone through the first part of it, that's the last class, and that will help us to quickly move on in this second part of the class. All right, so if you are ready, let's move on to what we have here. So we already discussed percent. We've talked about mathematical interpretation of percent statements. We discussed percent change, and what we have left is profit and loss, and then to take some standard examples on percent generally. So that's what we'll be looking at in this class today. We will be talking about profit and loss, and then we take some standard questions. So without wasting any time, let's move on to what we have for today. All right. Okay, so profit is equal to selling price minus cost price. So when you make a profit, it means your selling price is higher than your cost price. So that's when you make a profit. So to know the amount of profit you have made, you remove the cost price from the selling price to get the profit. Now we have profit percent. Now profit percent is simply the percent of your cost price that you have as a profit. That is, out of your cost price, what percent of it do you have as a profit? So profit percent is profit divided by the cost price times 100. Profit divided by cost price times 100. Also loss. Loss is cost price minus selling price. So when you make a loss, what does that mean? It means the cost price is higher than the selling price. Okay, cost price higher than the selling price means you sold whatever at a lower price than the cost price. So now loss percent will be loss over cost price times 100. Loss over cost price times 100. So we want to know what percent of your cost price is your loss. That's when we are loss percent. Now note that if a profit of 30% is made on a commodity, then the selling price of the commodity is 130% of the cost price. Okay, if a profit of 30% is made on a commodity, then the selling price of the commodity is 130% of the cost price. So here we're using this idea of our percent change to also work with profit and loss so that you can calculate faster. So if I have the profit percent given already, then I can use that idea so to calculate my selling price in a faster way. So if a profit of 30% is made, cost price on its own is 100%. So making a profit percent means you have made a particular percent of your cost price as your profit. So meaning you have added to your cost price. So cost price on itself is 100%. Now making a profit of 30% means we are now having extra 30% on our cost price. So which means we are having a total of 130%. And that is what will be our selling price. So that means selling price will be 130% of the cost price. Okay, so if I have a simple example, like let me say John made a profit of 30% on a bicycle he bought at $250. How much did John sell the bicycle? Okay, so John made a profit of 30% on the bicycle he bought at $250. So how much did John sell the bicycle? So as you can see here, now the profit percent has been given as 30%. He bought it at $250. So our cost price is $250. Okay, now since he made a profit percent of 30%, so what does that mean? it means that our selling price must be equal to 130% of this cost price. Yes, 130% of the cost price. That's why he has a profit of 30%. Cost price on its own is 100%, and your profit is part of the cost price that you have as your profit. So that means making above 100% of it. That's when you sell above 100% of your cost price, then you have the selling price and you make a profit. Okay, so the selling price here will be 130% of the cost price. So you just need to add the profit percent to 100% to make the percent of the cost price that will represent our selling price. So this gives us 130 over 100 times 250. So 0 eliminates 0, 0 eliminates 0. Okay, so we have 13 times 25. And what does that give us? That will give us $325. $325 as our selling price. All right, so that is the selling price. That's how much John sold that bicycle. So we've been able to do it straight away without wasting our time calculating the profit first. There's no need to waste our time to do that. You can find 30% of the cost price and add to the cost price to get the same answer. But instead of doing that, you can just simply do 130% straight away, and that gives you the result or the selling price of that bicycle. Okay? So, same idea we can apply on loss as well. If a loss of 10% is made on a commodity, then the selling price of the commodity is 90% of the cost price. Okay, so if you make a loss of 10%, that means you have lost 10% of your cost price. That is your loss, 10% of your cost. That means you have simply sold your commodity at 90% of your cost price. So the selling price will be 90% of the cost price. That's all. 90% of the cost price. That will be the selling price of that commodity. Okay, so this is how we can simply use that percent idea in our profit and loss questions, and that will help us to be able to solve the questions faster and easier. All right, so that's all we have to know about percent, everything we've discussed. All right, try to go through the two videos. So let's go and see some standard questions and apply some of the things we have talked about in these two classes. Now, okay, question 1. Question 1 says, today, the price of a table was reduced by 20% from what it was yesterday, and the price of a lamp was reduced by 30% from what it was yesterday. Quantity A, the dollar amount of the reduction in the price of the table. B, the dollar amount of the reduction in the price of the lamp. Okay, so first is, what are they asking you? Quantity A is saying the dollar amount, like how many dollars? $10, $20, $50, how much was reduced from the price of the table, and how many dollars was taken from the price of the lamp. Now, if we go back to the information we have here, the price of the table was reduced by 20% from what it was yesterday. Now, what was the price yesterday? And it was reduced by 20% today. Now, we don't know the price of the table. So, we don't even know the amount 20% will be. And the price of the lamp was also reduced by 30% from what it was yesterday. What was the price of the lamp yesterday? So that we can know what the 30% of that price will be. Now, since we don't know about anything about the prices of the lamp and the table, then it will be difficult for us to know what the 20% or what the 30% will be. Like how many dollars? What's the amount? The exact amount? That's what the question is asking here. Because it's talking about the percent. It's very clear. 30% removed for B, 20% removed for A. So I'm not asking us what the percent removed. If it's percent removed or percent reduction, it's clear B will be greater than A. But here they're talking about the dollar amount, not the percent. We only know about the percent, but to know the dollar amount, that means you need to know the price of the table and the price of the lamp. So since we don't know the price of the table, we don't know the price of the lamp, there's no way we can calculate the exact amount removed. You can only just know about the percent, but the amount you can't say, because If the price of the table was $100, that means 20% of $100 will be $20. That's quantity A. If the price of the lamp was $50, now 30% of $50 will be what? That will simply be $15. So our A would have been greater, even though the percent is smaller, but the amount will have been greater. But if they have $100, that means this will be $20 for A, this will be $30 for B, then B will be greater. So it's obvious here that we cannot determine this. We don't know which one will be greater or which one will be less. So our answer will be option D. It cannot be determined. Definitely, it cannot be determined because we don't know the prices. So we don't even know the amount 20% will be and 30% will be. So that is why this cannot be determined. So just try to understand the question. Because it's talking about dollar amount, the amount, exact amount in dollars, not the percent. If it's percent, fine, it's clear, B will be greater than A. But here it's talking about the dollar amount, which we are not sure of. So D will be the right answer. Alright, so that's question 1. Now question 2 says, a car dealer received a shipment of cars, half of which were black, with the remainder consisting of equal numbers of blue, silver, and white cars. During the next month, 70% of the black cars, 80% of the blue cars, 30% of the silver cars, and 40% of the white cars were sold. What percent of the cars in the shipment were sold during that month? During the month. And if you check this question here, it's a word problem question. It has many things. But one key thing you can notice here is that because talking about 70%, 80%, 30%, 40%, and again the question is saying what percent. So in a kind of discussion, when you are just talking about percent, and no number, no value, no amount is mentioned, everything is percent, and also because asking us what percent, then here we can decide to pick a value, all right, pick a number to represent the total number of cars shipped. All right, so that we can do that. So what with numbers make the work easier. But if you have another question of this type where a particular value is mentioned, maybe the question says 70% of black cars, 80% of blue, 30% of silver, and maybe 40 white cars, not 40%, but 40 white, then they have given you a number, not a percent. If they have given you a number, then you cannot pick any number for your total anymore. Alright, you cannot pick any number for your total. So once you're given a number, then you have to work with that number given to you. Get its percent and then use it to calculate whatever you need to calculate. Okay, but here everything is percent, fine, so we can easily pick any number. Now, it's very easy for any student to say, okay, I'll pick 100 because 100 always looks like a perfect number. But sometimes you have to be careful. 100 can work as well, but it will be giving you some kind of numbers you may not like to see. You may be seeing decimal numbers or something. And we always want to work with whole numbers, integers. So for something like this where you can pick your number, try to read through the question and see the number, a good number that will work for you. Now, first thing here is, it says half of which were black. So that means that number I want to pick, I want to divide it into 2 equal parts, half. Okay, now, with the remainder, that's the remaining half, consisting of equal numbers of blue, silver, and white. So that means the remaining half must be a number I can divide into 3 equal parts, equal numbers. So if I pick, I must pick a number such that when I divide it into 2 equal parts, then 1/2 of it must be a number that is divisible by 3. So you can reason with me and think of the perfect number that will be cool for us. Now, another idea you can use, you are dividing it by 2 first, that's half. Then after that, you want to take the remaining half and divide by 3. So dividing by 2 and also dividing by 3. So I'm thinking of a number that 2 can divide, 3 can also divide. Or simply a number 6 can divide. If you remember our divisibility rule, that means 2 times 3, which is 6. So we're actually looking for a number that I know that 6 can divide, a multiple of 6. Perfect. So I can even use 6, I can use 12, I can use 30, I can use 60, I can use 120, I can use anyone. Multiple of 6. So that will help me to get integers. I'll not be having fractions or decimals. Okay, so to answer this question, what number can we use? Alright, I will use 120. Okay, so you can use anyone and try and see if you get the same answer. But make sure you pick a number that is a multiple of 6. Number 6 can divide evenly. so that you know how to do fractions or decimals. Okay, so if I pick 120 as my total number, now let's search, let's see what the solution of the question will be. All right, so our total number of cars shipped, let's put it that way, shipped, that is 120. We're assuming 120. Now, question says half of which were black. So that means black cars will be half of 120, and that will be what? 60. Okay, 60. And then the question says again that equal number with the remainder consisting of equal numbers of blue, silver, and white cars. That means the remaining 60 consists of equal numbers of blue, silver, and white. So how many blues do we have now? How many silver? How many white? So that means we simply have 20 blue cars, 20 silver cars, and 20 white cars to make the remaining 60. All right, so we have blue cars to be 20, silver to be 20, and white to be 20. Okay, so that's why I'm taking the question gradually, step by step. Okay, now moving on. Now the question continues and says, during the next month, 70% of the black cars, 80% of the blue cars, and 30% of the silver, and 40% of the white cars were sold. Okay, so total number of cars sold, the sold, all right, 70% of the black, 80% of the blue, 10% of the silver, and 40% of the white were sold in that next month. All right, so let's write those ones out. So I will say sold. So we have 70% of the black, so that is 70%, that's 70 over 100, all right, times black, which is 60. And what does that give us? 0 eliminate 0, 0 eliminate 0, so 7 times 6, that gives me 42. Okay, the question says again that I have 80% of the blue cars sold. So 80% of blue, that's 20. So this eliminate this eliminate this, I have 16. The question says again that 30% of silver, 30% of silver, that's 20 silver you have there. So this, I have 6, and I have 40%, okay, of white cars, 20. So this, and that gives me 8. Okay, so all I need to do is, so total sold will be 42 plus 16 plus 6 plus 8. And when you add this, what do we get? 42 plus 16 will give us 58. 58 plus 6 will give us 64. 64 plus 8 will give us 72. So a total of 72 were sold out of the 120. Alright? So we have total number of cars sold, 72. Total number shipped, 120. Now the question says, what percent of the cars in the shipment were sold during that month? That's the question. What percent of the whole shipment were sold during the month? What percent of the cars were sold during that month? So we want to know what percent of the shipment was sold. Now, if you remember how when we talked about interpreting mathematically a statement like this, so that simply means sold over shipment times 100. Total number of sold cars divided by total number of shipments multiplied by 100. So what will be the final answer now? So sold over total number of shipments, all right, times 100. That's what we're going to have. So total sold is 72 divided by total number of shipments, 120. That's our 120 here, okay, times 100. So 0 here, eliminate 0, 12 here, 1 here, 6. So we have 6 times 10, and that means our final answer will be 60%. So 60% of the cars were actually sold during that month, 60%. And so the right option will be option what? So option D will be our right answer. Option D. 60% of the cars were sold during the month, during that next month. Alright, so that's how you answer this kind of question. So all you need to do is pick a value. As long as you're not giving any number, just pick a value to represent the total, and you can then use that to arrive at whatever you need to arrive at. Okay, let's see the next one. Next one says Kathleen's weekly salary was increased by 8% to $237.60. What was her weekly salary before the increase? Okay, Kathleen's weekly salary was increased by 8%. So already given a percent increase. So that means from the initial salary increased by 8% to give this new salary, the final salary. So what was her weekly salary before that increase? That was the initial salary. What was the initial salary before the increase? So here, just like what we've been talking about, so I can pick the initial salary as any variable, maybe X or Y or S or whatever. Okay, so that means I'm increasing it by 8%. That means I'm going to have 108% of that initial. So what that simply means that we are increasing the initial by 8. So if you increase X by 8%, then you have 108% of X. So if you are increasing initial salary by 8%, then you are having 108% of the initial salary. And that is now what is giving us 237.60. You get that? So what does that mean mathematically? This is what it turns to. So let's say let the initial salary be, let's say what? Let's say P. Okay, so now we increase this P by 8%. So what does that mean? Then it becomes 108% of P. So this is what gives that 237.60. That's what it means. So it means 108% of this initial salary is now this 237.60. And therefore, what does that mean? 108 over 100 times P is 237.60. Or 1.08p is 237.60. So this means P, which is the initial salary, will be equal to 237.60 divided by 1.08. And when you divide this, what does it give you? It gives you $220. Alright, $220. That is the initial salary of Kathleen before that increase, $220. Alright, now to the next question. Next question says from 2011 to 2012, Jack's annual salary increased by 10% and Annie's annual salary decreased by 5%. If their annual salaries were equal in 2012, then Annie's annual salary in 2011 was 1% greater than Jack's annual salary in 2011. Alright, so this is a good question, a little bit technical, but just see how we break it down and you can understand it perfectly well. So from 2011 to 2012, Jack's annual salary increased by 10% and Annie's annual salary decreased by 5%. That's it. So now, like I told you, always take your word problem questions line by line, statement by statement. The first statement expressing mathematically before you move on to the next one. So the question is talking about the change from 2011 to 2012, but the change is not about one person now, it's about two people, Jack and Annie. So the good thing I can do here is to separate the analysis. Let me do Jack on one side, Annie on one side, and then see what it will be at the end of the day. Okay, so let's say that we have Jack on this side and then Annie on this side. Okay, so we have 2011 salary Let me put it that way. And then there is 2012 salary for Jack. Then for Annie, same way, we have 2011 salary, and we have 2012 salary for Annie as well. Okay, so here let's say Jack's salary in 2011, let's say J, and Annie's salary in 2011, let's say A. Okay, so we're just talking about the change in the salary from 2011 to 2012. So we need to know, since from 2011 to 2012, let's pick values for the initials, just like we did for Kathleen in the last question. The initial salary, let's assume J for Jack in 2011 and A for Annie in 2011. Now the question says that from 2011 to 2012, Jack's annual salary increased by 10%. So Jack had an increase of 10%, and Annie had a decrease of 5%. Can you see that? So Jack increased by 10%. So that means, like we said, if Jack's salary was J in 2011, that means 2012 it was now 110% of J, 10% increase. While Annie was A in 2011, now in 2012 it will be 95% of A. That's 5% decrease. 100% minus 5%, 95%. While Jack will be 110%. Okay, so let's write those ones out. So in 2012, Jack will have 110% of J, which is equal to 1.1 J, and Annie would have 95%, all right, 5% decrease of A, which is equal to 0.95 A. Okay, you can see I'm taking it line by line. All right, so that's what we have so far. So let's continue with the question. So the question continues and says, if their annual salaries were equal in 2012, can you see that? In 2012, the salaries were equal. What does that mean? Meaning 1.1 for Jack, now equal to 0.95% for Annie. Then Annie's annual salary in 2011 was 1% greater than Jack's annual salary. So the best thing we need to do is to express Annie's salary, that's A, in terms of Jack's salary, that's J, for 2011. Okay, so but this statement is what is very important for us. Their salaries in 2012 were equal. So what is Annie in terms of Jack? In 0.1%, nearest 0.1%. So let's see what that will be. So the question says their salaries in 2012 were equal. So what does that mean? 0.95A is equal to 1.1J. Yeah, they were equal. 0.95A is equal to 1.1J. And so, since we want to get Annie's salary in 2011, that's A, in terms of Jack's, I want to know how many percent greater than Jack's salary in 2011. Okay, so we express Annie in terms of Jack. That is, make A subject of this equation. Okay, so that means we have A to be equal to 1.1J divided by 0.95. So if you divide 1.1 divided by 0.95, what do you get? We have approximately 1.158 of J. 1.158 J. Okay, now how do we interpret this from what we already discussed in our last class? All right, under percent, like I told you. So for you to know the percent relationship between this A and J, as the question is asking, Annie is how many percent greater? Like I said, then you have to express this value in percent, and that means move your point 1, 2, so is equal to 115.8% of J. And what does that tell us? This implies that Annie's salary in 2011 was 15.8% greater than Jack's salary. in 2011. So our answer in to the nearest 0.1%. All right, that means one number after a point. That's one decimal place. All right, so our final answer will be 15.8%. Okay, as you can see here, so we just pick the extra over the 100. So if you have 115.8, that means it is 15.8 extra. So 15.8 greater than Jack. So Ali's salary in 2011 was 15.8% greater than Jack's salary in 2011. So our final answer will be 15.8% to the nearest 0.1%. So you can, when you approximate, you get that. So 50 point. You have to ensure, because this is a numerical entry question, so you must get the exact answer, not 15.7. So when you do your approximation, since we needed one number after the decimal point, we had to make sure that we approximated to 3 numbers after point, so that when we move our point to get the percent, we'll have one number left. So you approximate to 3 decimal places so that you can have one decimal place when you take it as a percent in your final answer. So our final answer will be 15.8%. Okay, so that's the solution to that question. You can type your answer here, 15.8, as a final answer. So you don't need to put the percent sign, only just 15.8 here. Okay. All right. So let's look at this last question. It says a dealer sold a car at a 25% profit and another car at a 25% loss. If the selling price of each of the cars was $210,000, how much profit or loss did the dealer make on the 2 cars? Okay. So here we have 2 cars. All right. So let me say car A, car B. All right. Now we don't know the initial cost price of these cars, but according to this question, we know that the dealer made a profit of 25% on the first one when he sold it at $210,000, and made a loss of 25% on the second car when he sold it at the same $210,000. So we now want to know, did the dealer make a loss or profit over the 2 cars, and then how much profit or loss did he make? Okay, so let's just analyze the 2, just like we did for Jack and Annie the other time. I will separate them as well, car A and then car B. All right, so let's look at the solution. So let's say car A, and here I have car B. All right, now for car A, the cost price I don't know, so let me say CA. And for car B, the cost price I don't know, so let me say CB. Okay, now the question says that each car was sold at $210,000. So that means the selling price for the first car, $210,000. The selling price for the second car, $210,000. All right. Now, don't forget from the question, the dealer made a profit of 25% on the first car and a loss of 25% on the second car. So it means for the first car, the man sold the first car at 125% of the cost price. At 125% of the cost price. That is, the selling price here for car A is 125% of the cost price, CA. Because like I explained, if you make a profit of 25%, then your selling price is 125% of the cost price. Okay, and the question says again that the dealer made a loss of 25% on the second car, another car at a 25% loss. And what does that mean? It means the second car was sold at 75% of the cost price. 75% of the cost price. A loss of 25%, that's to move 25% from 100%, so 75% of the cost price. Okay, so our selling price for the second car will be 75% of the cost price. Okay, now Let's now see. We already know the selling price to be 210,000. So it means here I'm going to have 125% of my CA to be 210,000, or 1.25 CA is 210,000. So from here I will be able to calculate the cost price, because if I need to know the profit or the loss or whatever, I need to know the cost price of each car. So from here it means the cost price for the first car will be 210,000 divided by 1.25. And when you calculate that, what do you have? You have $168,000. That's the cost price for the first car. So that's why he has a profit. Now, for the second car, as you can see here, it means 75 over 100 of the cost price will be equal to 210,000. Okay, or 0.75 of the cost price is 210,000. So that means the cost price will be 210,000 divided by 0.75. And when we divide this, what do we have? So the cost price for the second car will be $280,000. All right, as a cost price for the second car, and he sold it at 210,000. You can see he made a loss truly. Okay, so now we want to now see overall total profit or loss. So what do we need to do here? What we just need to do is first find what is now the total cost price of the two cars, and that will be what? 168,000 plus 280,000. And when you add this together, what do you have? You have $448,000 total cost price for the two cars. $448,000. Now, what is the total selling price for the two cars? So total selling price of the two cars will be equal to, so the first one is 210, second one is 210, so that will be 210,000 plus 210,000, or 210,000 times 2. All right, giving us 420,000. Now, profit or loss, you can see total cost price 448, total selling price 420. Which one is bigger? Cost price is higher than the selling price. So if cost price is higher than your selling price, what does that mean? Then there is a loss. So what's the loss? The loss will be equal to the cost price 44800 minus the total selling price 420,000. And when we subtract that, what do we have? We have $28,000. So that means the man made $28,000 loss. That's our answer. $28,000 loss. That's the total loss or profit the man made. But here it's a loss. It's a loss. $28,000. So our answer will be what option? That will be option D. Option D. $28,000 loss. $20,000 loss. All right. So that's the answer to this kind of question here, where you can apply your profit and loss percent idea. Okay. So with that, you have come to the end of the topic percent, and also the end of the first aspect of the GRE quantitative reasoning, that is arithmetics. So you've been able to run through all the topics under arithmetics. All right, so that is, we went through number properties. All right, we have about 3 videos on that. So the first 3 videos. After that, we did sequence. After that, we checked fractions. After that, we did decimals. After that, we did real numbers, ratio, and proportion. And then this last one, which are 2 videos, that's percentage. So we've been able to cover everything under the first aspect, which is arithmetic. All right, so I want to believe you have learned so much on the topics under arithmetics, and from the next class we are moving on to the next aspect, which is algebra. And I want to believe you'll be ready for that when we start. All right, so That's where we'll stop for today, and get ready and prepared for the next aspect, which is algebra. So you can take your time, go through the videos again, look at the questions again, practice more and more and more until you get better. And I will see you in the next class. Take care and bye.